So welcome back to the conclusive section. So till now, you have done some awesome AI projects. First, you did something with CNN and ran a vehicle in autonomous mode in the simulator. That was really awesome because you learned a lot about convolutions, you learned a lot about what kind of features to look at in the environment, and then ran the vehicle autonomously. That was really, really good. Then you learn about reinforcement learning and the game AI agent. Here you ran the Google Chrome Run game in autonomous mode using reinforcement learning techniques. And you could see that the agent was able to navigate through the obstacles without any help from you, since you had trained it to achieve maximum score. That was also a really, really good project. Then you learned about neural network style transfer, first using CNN. So you blended two artistic styles. And then you did similar project using GAN, which was a completely different paradigm to look at deep neural networks. So this is a new paradigm which you also learned. So awesome, but there are of course problems in this deep learning research community, which people are working on actively to find out the solutions for and make it better. So let's look at the problems in the different deep learning methodologies. First, you look at CNN. So the main problem in CNNs are like overfitting, then reacting to unknown data stream, because we always train it with some label data, so we don't know what will happen to the unknown data stream, whether it will perform good, bad. This is very, very dicey. And you need huge amount of labeled data for training. That is also a drawback. CNN also doesn't work well on temporal sequences. We have something else for that, but CNN doesn't solve it. So it doesn't provide a silver bullet to all the problems. And there is a huge issue in fixing the hyperparameters. For example, learning rate, weight, decay, batch size, activation functions. So you have to experiment a lot to find out what is best for you. And if you consider the active area of research in CNN, those are basically RNN and LSTM. So RNN is recurrent neural network and LSTM is long short-term memory. Both are good for giving you some sequential kind of output and results. Then we have autoencoders. What are autoencoders? Sometimes it is the neural network simply learns to duplicate the training data instead of learning general concepts from the training data. To avoid this problem, often the training set is augmented by creating replicas of observations with added random noise or jitter. Single hidden layer or autoencoder network with noise added to the training data is known as denoising autoencoder. But you may wonder, why is autoencoder network are generally useful? It has been shown to be surprisingly adept at feature extraction. That's what autoencoder is good at. You can use it in more than one hidden layer to construct a stacked denoising autoencoder, where each consecutive layer in the network can be optimally weighted, nonlinear, lower dimensional projection of the training data. You can stop there and use the autoencoders for feature extraction. Or they are also used as pre-training mechanism for deep supervised networks. Autoencoders basically helps you to give a generalization of your training data or learn the features from it. Then another trend these days is CNN pruning. Generally, pruning means that we have to discard what we are not using. So similar concept in CNN as well. So here, with the help of novel reward function, the agent removes a significant number of filters in the CNN while maintaining the performance at almost similar desired level. Moreover, this method provides an easy control of the trade-off between network performance and its scale. Because you sometimes using CNN, you have to do many operations at real time. So pruning of the unnecessary things is really, really good. Another trend in CNN these days is active learning. So what exactly it is? In active learning, the algorithm gets a lot of data, but not the labels. The algorithm can then explicitly request labels to the individual examples. This can be helpful when we have a large amount of unlabeled data and we want the examples that we label manually to be as helpful for learning as possible. So let's say you want to find faces in YouTube videos. The label for the algorithms would be bounding boxes around the faces in each of the video frame. However, there are so many video frames with so many frames that it is impossible to label all of them manually. So what we could do, we could just label 100 videos frame by frame, but that would be a lot of wasted effort. Since the following frames are often similar, the algorithm might not benefit very much from each consecutive frame being labeled. In active learning, the algorithm tries to both learn the task and tell us what labels would be most useful for the current state. We can then label just those frames which are useful so that the manual effort is directed in the best way. So that is like active learning. The machine tells you what it wants to learn. If you want to more about CNN, like convolutions for visual recognition, I would recommend you to look at this Stanford course. This is much more exhaustive and it takes much more time to complete it. But if you have time, then you should do it. And if you want to see some video lectures, I would recommend you to watch the video lectures from Andre Karpathy. The lectures are available on YouTube, and this is the link. And for more theoretical background of deep learning, I would recommend you to read this book on deep learning by Ian Goodfellow and Yoshua Bengio and Aaron Kovile. So they have this website, deeplearningbook.org. This is also available online. You can have a look.